So looking at this Honda Odyssey out here in the graveyard, found what seems to be the EGR here right next to the back of the cylinder head. Has a 5-wire connector going to it. As you can see, it's connected, bolted to the back of the head, and has a runner going to the intake manifold.
So here we are looking at the wiring diagram for this Honda Odyssey. And as you can see, we've got a linear EGR setup, and what that means is that we've got our electromagnetic coil over here, and then we've got our potentiometer circuit over here, and those work together to control the EGR. So it's a 5-pin circuit. Over here, it's pretty simple. We've just got our ground here and our power here. It's power side driven, which is honestly pretty unique for a system like this. And then over here, we've got our potentiometer, which is going to be our reference voltage, probably 5 volts coming through from the PCM, getting grounded over here also at the PCM. And then we've got our internal resistor and our little voltage probe that's going to go up and down across that resistor in order to change the voltage that the sensor is sending back to the PCM. So here we are looking at the PCV system on this 2011 Chrysler 300. Here's our PCV valve itself. We've got a variable flow PCV valve, which means you can shake it. I'm not sure if you can hear that rattling, but because it's rattling, that means that our PCV valve doesn't necessarily mean that it's good, but it means that the valve itself that's in there that creates the variable flow isn't damaged and it's not stuck and it's flowing as it should. So this is where our PCV valve goes, right in here. And here we've got our vacuum side that's going straight to our intake manifold. Obviously you can see it's behind our throttle body here, which means that we've got full intake manifold vacuum going to this line, going here. And here is going to be our fresh air hose going straight to our oil cap and coming from our air box here. So we've got our fresh air coming in here, washing the dishes, coming out of this PCV valve, getting sucked through this vacuum into the intake manifold where it's getting burned again.
All right, looking at the Chrysler 300 now, we're gonna go ahead and do the dollar bill test here for the PCV system. Gonna put a dollar bill on top of this oil filler cap right there. We're looking for testing for excessive crankcase vacuum or pressure. We're trying to get just slight bit of crankcase vacuum is ideal. If we have excessive pressure where it's blowing the dollar bill out, or excessive vacuum where it's sucking it in, that is an indication of a bad PCV valve. So we'll start it up here. As you can see, when we're doing the dollar bill test, it's just sitting on there. It's blowing out a little bit. Nothing major though, it's just sitting on top. Can pull it off very easily, so I'd say this PCV is functioning properly.
All right, so here's the PCV on this Chrysler 300. And it's, as you can see, it's integrated into our valve cover, into our intake manifold. And here is the PCV valve itself that I just removed. You see if I give it a little wiggle. You can see that it's rattling. You can hear that when I shake it, which means that our valve itself is able to move freely, and that's a good sign. If it was clogged, then our PCV system would not be working properly. So what we're about to do is we're going to do that dollar bill test again, but with this PCV valve removed, which in theory will just create a vent right here that will vent all of our PCV gases, our crankcase pressure. It'll vent it directly to atmosphere. And so we should see no change over here, but there should be pressure coming out of this hole where this PCV valve used to be. Alright, so let's put the dollar bill here. Honestly, it's about the same as it was. Oh, we've got vacuum. So what we realized when we did that test is we originally thought that we would have crankcase pressure coming out of this hole right here where our PCV valve was. But as soon as we did the test, obviously, we realized that we had vacuum there. And that vacuum was actually coming from this line. It was pulling straight manifold vacuum all the way to this little hole right here. And that was what was giving our dollar bill such crazy suction. When you covered this hole, there was a noticeable difference in how the engine was running, obviously, because that's a pretty big vacuum leak that we've created. And so that's what was sucking the dollar bill down.
All right, so still on the 300, we pulled up some PIDs of our manifold vacuum, our MAP reading because this is a speed density system, so it does not have a MAF sensor. Our idle speed, as well as our upstream, one of our upstream O2 sensors, as you can see, switching back and forth. We're going to be creating an unmetered air leak straight right in the manifold right here. See what that does to our PIDs, and also see how it affects the running engine with a leak in the PCV system. All right, now we're going to be creating an unmetered air leak. It shouldn't affect it as much theoretically. As you can see, our engine really started to struggle, still struggling to run. Our oxygen sensor struggled, didn't switch there for a second, stayed lean for a good minute, still struggling to switch. It's completely off now. It's 0 volts, not even reading anything. Engine speed is just, as you can see, not as consistent as before, as well as manifold vacuum, because we have an unmetered air leak now. You can also still tell that the engine is obviously running a lot rougher, so vacuum leaks still can make a speed density system run rough, especially this major of one.